All set.
Great, thank you. Uh, Good afternoon. My name is Eric Howard. I'm the Executive Director of the E2 Tech Council. Today's webinar is talking about integrating clean on-site energy technologies with two experts from the On-Site Energy Technical Assistance Partnership Program of the U.S. Department of Energy. It's a program that's managed through the University of New Hampshire. Before I pass the baton on to Matt Davis and Suzanne Watson, I have a couple of quick slides. First is sort of the general picture here in Maine. You probably have heard about all the different programs coming from the Governor's Energy Office. Recent reports talking about 15,000 jobs, major contributor to the state economy. Looking toward the future, the expectation is that we may actually have 30,000 jobs in the clean energy sector by the year 2030. So there's lots of job growth happening. Some of it will be younger Mainers who are entering the workforce. Others are changing jobs from one sector to another. And then we also have obviously some in-migration. I have a quick slide here showing these are some of the jobs over the last few years in energy efficiency, renewable energy power generation, grid modernization, renewable fuels. And this is a slide coming from the Efficiency Maine Trust showing the vendors that the Efficiency Maine Trust works with. And you see they're pretty much everywhere in the state where people live. So our sector is not just Southern Maine. We're Bangor, we're Aroostook County, we're Washington County, as well as in the Western Mountains. The E2 Tech Council is Maine's largest community for environmental and energy professionals, with hundreds of member companies and institutions, thousands of people on our mailing list, and numerous partner organizations. What we do is we help convene meetings. We're a catalyst. We try to be a credible resource, which is part of today's program, and we're an important connector. I'm particularly excited today to have Suzanne Watson with us, since she was one of the people who was instrumental in starting E2 Tech many years ago. She served on our board, she served on program committees, and she's been a consultant in the clean energy sector for many years. Suzanne is joined today by Matt Davis, who's the director of the On-Site Clean Energy Program. He's been on the faculty of the University of New Hampshire for many years. And he's an expert in ground source heating. And he will now share his screen and be in control of the slides from now going forward. So Matt and Suzanne, it's a pleasure to have you both with us today. And thank you to the others for joining our webinar.
All right, thank you, Eric. Thank you for that introduction. Does that look okay on your screen?
No.
No. Okay, we did all the planning, right? All right. No.
Try it a second time. We did this 15 minutes ago and it worked perfectly.
It worked perfectly.
Yeah. Anyway, thank you for your patience. Let's see if it works well the second time. That's perfect. Yes.
Looks great.
All right. Well, thank you, and thank you for joining us. Thank you for taking time today to hear about this new Department of Energy program looking at on-site energy and the technical assistance aspect of that. I'm Matt Davis. I'm the director of the New England Technical Assistance Partnership. There are 10 other regional TAPs that we'll talk about. And we're happy to have Suzanne Watson as part of our team as a consultant, as she brings a lot of experience and expertise to this project. So we're grateful to have her on the team and grateful to have her joining us today. So there's a lot to unpack here. We're going to go through this, in detail. We're going to dive into it a little bit more as we go through the webinar. The program is aimed at overcoming barriers to adopting clean energy technologies. And we're particularly focused on industrial facilities and large energy users. And we can talk more about what qualifies as large energy users. But we're trying to move forward the decarbonization initiatives, and the industrial sector is a big part of that. The on-site energy program consists of these 10 regional TAPs, the Technical Assistance Partnerships. There's one in each region. And each of these then work with the energy users in their regions. And then we work also together with them as they complement our expertise, we complement their expertise. And we also have a national team of experts, as well as the national labs that we work with in doing our evaluations. The New England regional TAP is, as Eric mentioned, funded by a grant to the University of New Hampshire, where we are located. The TAPs work with these energy users, right, to evaluate these different opportunities and trying to overcome the barriers that we've seen towards adopting these technologies. So the barriers to moving to this energy transition away from the business as usual, you need a place to start. So a company might see that they need to replace equipment. They want to participate in some renewable energy incentive programs. They want to improve efficiencies, and they don't know where to start. So a lot of these companies have these desires, but they don't have the technical expertise on staff to undertake that analysis. And that's where you start. You call us, the Technical Assistance Partnership, and then we work with these users to understand their energy usage patterns, to understand the facility characteristics, and then to do an assessment of the potential technologies for that site. Our evaluations are at no cost and no obligation. They're simply to provide an objective starting point for further analysis and support. We'll largely collect our information offsite. Unlike if you're familiar with the industrial assessment centers, we do not do on-site measurements. It's largely done remotely. We will do site visits to be sure that we understand the facility and the needs of the user. When a user decides to move forward with our recommendations with a project, we continue to help that entity through that process. And I'll talk more about that later on. One of the advantages of having a TAP do an assessment is it opens up the eligibility for a grant program that consists of $300,000 matching grants per quarter. So an individual site may be eligible for up to $1.2 million a year of matching grants to help implement these technologies. As the name suggests, on-site energy involves a lot of different technologies, and our assessments consider all of the technologies that may be suitable for that site. The end user may end up deciding to use some, of those technologies, a subset of those technologies, but we really want to be sure that we're leveraging all of the technologies that are available to reach some optimal recommendation for the user. This is a long set of technologies that are listed here. We're going to talk about some of them in more detail. Our goal, again, is to provide actionable information to the end users. We focus on technologies that are fully commercialized. A number of these technologies are still undergoing research and development. In some cases, there may be an opportunity to partner with the DOE for demonstration projects, and we can help identify those opportunities and connect users with the appropriate programs for that. So how do these technologies benefit a business? So on-site energy can improve resilience. So for example, a battery system can allow operations during power outages. Hospitals will often use combined heat and power systems as the backbone for a microgrid, so they can continue operating through outages. These technologies can reduce operating costs. For example, geothermal heat pumps use renewable energy from the ground, which displaces the need to purchase fossil fuels such as natural gas, fuel oil, or propane. The operating cost for a ground source heat pump system is about 1/3 of the cost compared to heating oil, so you're offsetting that fuel cost. To reach the state renewable energy targets, users can monetize the energy produced in the form of renewable energy credits, or RECs, and we'll talk some more about how the RECs fit into this. So through net metering, it's also possible to sell energy into the grid, and we're going to talk about another program specific to Maine that allows for owners of battery systems to essentially sell power into the grid at a higher rate. When we combine solar PV with battery storage, we have an opportunity to operate more flexibly, where the batteries can be charged when energy prices are lower for a time of day, and then that energy can be dispatched during times of higher cost. So many of the financial incentive programs stem from the state level renewable portfolio standards. Maine's RPS is aggressive and forward-looking, as a 2035 target of 80% renewable. While the state level RPS legislations, right here it's shown for each state, continue to advance, continue to incentivize the deployment of renewable technologies, it's increasingly recognized that renewable is not necessarily the same as emissions free. So when we try to combine our RPS that highlights renewables, such as biomass, renewable natural gas, in the case of Maine, black liquor can be used as a renewable fuel. Those don't necessarily align with reducing emissions. So we work with the end user to help understand the emissions reductions that would be possible from these different technologies. And the states are also beginning to implement policies that recognize the need to bring in nuclear power from Canadian hydro into their procurement process to attain the emissions reductions, even though those technologies are typically not part of a state renewable portfolio standard. So this report is from a recent study done by the Maine the Governor's Energy Office. In that report, they also recognize the limitations from the current grid capacity. And they found that Maine cannot meet its renewable energy goals solely by increasing generation. So the limitations on the grid are one additional barrier to meeting the renewables portfolio standards and the emissions targets. So this has spawned some interest in programs that are often referred to as non-pipeline alternatives or non-wire alternatives. And I understand this group is interested in leveraging artificial intelligence to help with the energy transition. And so managing some of these systems that we'll get into, artificial intelligence is often necessary to deploy them. So this is one example in Maine of a program that is looking to deploy on-site energy technologies to improve grid resiliency. And we're happy to learn about other programs. This is one that we've come across that aligns well with our work. And in this case, Efficiency Maine is working with Central Maine Power to get more large energy users to deploy battery storage systems that will reduce the load from the grid during peak times. So when we look at the demand on the grid, you probably are aware of this, but one analogy is, a highway system. And when we have centralized production and we're distributing that over the grid, we need to be sure that the grid has sufficient capacity to meet that 1 hour peak demand in the year. And so one analogy is that we often end up with these 8-lane highways that are only necessary for 1 hour of the year. And when we look at on-site energy, this is a distributed energy resource. And so we need to then look at how we get the distributed energy into the grid. And it's different than if we were just building out the grid using the same production distribution that we've used historically. And so this then involves a lot of controls, and it involves a lot of managing these assets. And again, this is an opportunity where artificial intelligence can really help with these distributed energy resources. So it can look at the weather forecast, it can look at historical data, it can begin to anticipate where and when these peak loads are going to occur. So this program, pays the owner of the asset. This is a behind the meter program looking for large energy users to reduce their energy usage during these demand peaks. And so by dispatching that battery to the facility itself, reduces the load on the grid. And so this is a program that provides $200 per kilowatt hour during these peak periods. So some of the financial incentives focus on the operating costs, right? RECs are minting of renewable energy production, where 1 megawatt hour is 1 REC. Those RECs can then be sold to offset some of the costs. Net metering is another way to reduce the operating costs. There are performance incentives like the battery energy storage program that I just mentioned. In addition to the savings, operational savings, there are also opportunities to reduce the upfront capital cost. And so the investment tax credits is one of these. And this is something where we are not tax experts. We can help the users kind of navigate this landscape and point them to opportunities that they might not have otherwise been aware of. One of the opportunities now is that the Department of Energy has designated a number of communities as disadvantaged communities. And that then results in a 10% adder onto the tax credits for projects in these disadvantaged communities. There's also, as I mentioned, the Industrial Assessment Center grants that are $300,000 per quarter up to $1.2 million per year that provide a 50% match for these projects. So the TAP can help navigate through these. Our assessments include these financial incentives as we look at the different technologies and the return on investment. This is a map of the disadvantaged communities in Maine. And so for projects in these communities, there are additional financial resources that are available to get these projects moving. The communities are based on a large number of 36 indicators, right? But some of the primary ones are the fossil fuel dependence of the community. What is the energy burden on the residents in those communities? Environmental and climate hazards, socioeconomic vulnerabilities, and all federally recognized tribal lands are included in this. So for these projects, right, we will look into see if they are eligible for some of these additional financial incentives and can assist the users in navigating through those. So now we've looked at some of the goals of the program, the policy framework, spent a few minutes talking about some of these technologies. Some of you may be familiar with these, some of you may be experts, more expertise in these than I am. But just to go through some of the common technologies that we are looking at as we do our assessments with different facilities. So combined heat and power, cogeneration are well suited for facilities with a high thermal load, where traditionally you would have boilers creating steam or hot water. You would have grid power providing the electricity. With a CHP system, you can harvest the waste heat from the electricity generation and use that for the process loads. And in some cases, you can use the excess heating to also generate electricity. So there's a couple of different CHP configurations that are possible depending on the energy usage and the loads and the temperatures that are required. And these can be powered by natural gas. They can be powered by renewable natural gas, wood chips, and biomass. And in Maine, black liquor is also eligible renewable energy for these systems. As we look towards decarbonization, right, we want to get away from combusting carbon-based fuels, whether it's fossil fuels or biomass, towards other non-emitting fuels. And so these combined heat and power systems are increasingly being built so that they can operate on hydrogen as a fuel or a blend of natural gas and hydrogen. Heat pumps are another important technology. These come in a variety of configurations with different specifications. Geothermal heat pumps are, an area that I'm quite familiar with. And one example in Maine is the Portland Jetport that has, I think, 127 vertical boreholes that's meeting the heating and cooling demands for that facility. And so those geothermal, or often water to water or water to air heat pumps, are a kind of a subset of these industrial heat pumps. And the geothermal heat pumps have they can take source temperatures of 40 degrees Fahrenheit and produce air temperatures of 100 degrees Fahrenheit, right? That's suitable for meeting the heating and cooling for a building. In some process loads, you need higher temperatures. You also have different thermal sources. So you can capture thermal energy from waste heat, and you can use that and use a heat pump to then elevate the temperature to the required temperatures for these different processes. So in this case, we're looking at the traditional vapor compression cycle that is the basis for many of the heat pumps. But the industrial heat pumps, different working fluids can be used, different mechanical processes can be used. And so there's a lot of different ways in which heat pumps can be used to meet industrial needs. They're trying to get the temperatures up, to higher than 100 degrees Celsius. Right now, the commercially available heat pumps kind of top out at about 100 degrees Celsius. And this is a temperature that can be used for food processing, textiles, and metal plating. Solar PV is a very common renewable energy technology that I think you're all familiar with. And large energy users can often take advantage of unused roof space or carports, right? Open space for field arrays of solar PV. Maine has the largest solar PV capacity in New England, which was somewhat surprising when I looked at that. And ISO New England expects this to continue to grow rapidly over the next decade. So we will often look at solar PV as part of the portfolio of technologies when we do an assessment. Battery storage systems are another increasingly important energy technology that's deployed on site. With the Efficiency Maine and Central Maine Power Program, right, these assets can be monetized through behind the meter demand response and other grid services programs. They also provide some flexibility for the operation of the systems. They can reduce the demand charge by deploying the battery to reduce the site demand, which then can reduce the demand charge on the energy bill. There's been a lot of press about this large utility scale battery system that's going in Gorham that has a rated capacity of 175 megawatts. So we've talked about some of the barriers, the awareness of the technologies. So we're trying to improve the awareness of the technologies over the next couple of years. We'll be looking at project profiles to get some of this information out into the more bite size for end user consumption. We've talked about some of the financing opportunities. And so let's look more at the technical assistance and the evaluation of the suitability for specific facility or and the energy uses patterns for that facility. So a lot of what we do is around technical assistance, right? The technical assistance partnership. And we work with entities to understand their energy needs. And we will collect data and evaluate those data, understand the process loads, understand the current use of energy, different fuels, and together we will then work to develop a plan for some different options. And the initial evaluations are relatively straightforward, a high-level view of energy needs, the technologies that can meet those needs, and then looking at the return on investment and the emissions reductions that would be achieved through those different options. Again, these evaluations are at no cost. There's no obligation. One of the barriers is simply getting kind of quality, unbiased information into the hands of decision makers and people who are going to evaluate the suitability of these technologies for their individual sites, right? We would like to see the projects proceed, but it's entirely up to the end user, right? They may simply want an assessment to update their planning, right? That's fine. They may want an assessment to look at their sustainability portfolio. So, we will do the assessment, and then it's really up to the end user to use that in whatever way meets their needs. We also provide technical assistance from that initial screening through the design and installation phases. Now I'll go to this next slide here. that kind of is an overview of the process, at least for the what we call our initial technical assessments. So if there's a facility that has an interest in evaluating different energy technologies, right? The first step is to call me, call Rob, reach out to Suzanne, and then we will then set up a meeting to do an intake where we go through some of the high-level characteristics about what is the energy usage on the site, learn more about the facility needs, and what are the energy-related goals, right? Then we will then look at that information. We'll evaluate how that meets in with our program requirements, right? Is it a large energy user? Are there multiple technologies that may be deployed? And then we will look at that some more. So there are a lot of businesses and vendors out there who are already doing assessments for individual technologies. So the solar industry is well established, right? They'll put out quotes for a solar PV array. And what we're trying to do is not to interfere with that, but to provide information about what other technologies may be suitable, right? In addition to solar PV, or maybe there's a vendor who is talking about a combined heat and power. So that's all wonderful. And we can work with those vendors and the end user to expand the view and look at a suite of different technologies so that the end user can then be sure that they're making the best choices when they do their planning. So once we complete the intake process, we go to the site, we collect the site data, and unlike the industrial assessment centers, which kind of preceded us, and they're still active, but not as much as we would like in New England. Most of the data that we collect can be obtained through energy bills, through monthly energy bills, electric bills, fuel bills, an understanding of how much biomass is used. So we use that kind of high-level energy usage data at a monthly interval to then come up with an initial technical assessment. The analysis takes a few weeks. So we do an initial intake. We will then continue talking with the end user to see if they want to continue with it and provide the energy data. We don't want to be wasting people's time to provide a bunch of energy data if it's not going to meet our program needs or if it's not going to meet their needs. So after that initial discussion and the collection of that data, we have a team of technical experts that really serve the national program. And so we work with them to develop these assessments. We also have the national labs at our disposal. So when things come up that are not routine, we can go to the national labs and tap into that resource as well. So we have the report. It's a 5 to 10 page report. It has an evaluation of different technologies, costs associated with those technologies, the financial incentives that are available, the bottom line cost, and then a return on investment. So we review those with the end user, and then the end user can then take that report. That report then makes them eligible, and depending on some other criteria, to apply for some implementation grant opportunities. That information can be used for their planning purposes to talk with their vendors about what we've recommended. When end users put out a request for proposals to do a design, we can work with those end users as they're putting out that request. If they have questions about it, we can help them be sure that their request for proposals has all the necessary information. And then as they're going through the design process, right, we'll still be here to help answer questions that may come up during that design and installation process. So this slide is showing kind of the initial technical assessment, but as you move to the right off the slide, there's ongoing assistance that is provided. So we are the New England Regional TAP. We're located at the University of New Hampshire. There's our contact information. I will make these slides available to the E2 Tech folks and reach out to us if you have questions, if you have facilities in other states and other regions, if you have colleagues that you think might be interested in engaging with the on-site TAP. Happy to work with you to determine which TAP that would be and put you in contact with them. The on-site energy program is through the Department of Energy, Industrial Energy and Decarbonization Office. We've just completed the first 6 months of a 3-year grant. So we're going to be around for a while. We're still reaching out to stakeholders in different regions. So we, again, appreciate the opportunity to meet with you all today. If you have questions, please put them in the chat. Reach out to Suzanne or myself or Rob, and we'd be happy to answer those. Let me stop my share.
Great. Thank you so very much, Matt.
You're welcome.
I think I guess the opening up for questions. One of my questions that came to me while you were talking was the relationship between the services that you're offering and what the main manufacturing and extension partnership does. Again, you're both two different programs, both funded by the federal government in part, and slightly different.
Yeah, so we're working with the MEPs in different states. MEPs are really looking at a number of issues facing manufacturers, workforce development, supply chain. One of the things in their portfolio is energy, but we're kind of I think a small part of the MEP's overall mission.
Okay, yeah. In Maine, we obviously have sawmills. The paper mills aren't as active as they were 10 or 20 or 30 years ago. What are some of the other larger energy users that you'd love to be engaging with?
Yeah, we definitely want to get in touch with the pulp and paper industry. It's a big energy user. They've been going through a lot of hard times. We want to be sure that they're at least aware of us. So if you all have connections in that industry, we want to be sure that they're aware of this opportunity. And the agriculture is another, and wood products, right? So not only pulp and paper, but also wood products in general. And there's a lot of waste, bio-waste wood products that are associated with some of the production. And so those can be used as a fuel or a combined heat and power system. So they can produce their own electricity. They can produce the thermal energy they need for drying. And so the combined heat and power is very, very much of a good match for wood products. And we want to learn from you all about what industries are out there in Maine. I think the food processing industry is another one that we'd be very interested in connecting with, and the problems of cold storage and how can cold storage be, efficiencies be gained through some of these technologies.
Suzanne, are there other sectors that come to mind?
Well, we've been working, I guess the previous CHP tap that was working in New England and Maine over the last 5 years, we found that the brewing industry, beer brewing, is a big sweet spot. But and speaking of sweet spots, we're looking at chocolate making also. So beer and chocolate seems to be a winning combination.
Yep, yep. Wilbur's Chocolate in Freeport just installed solar panels that was done by one of our members, Maine Community Solar.
Interesting. I've been meeting with Tom Wilbur about trying to use our Onsite in addition to what he's already installed. What else might he do?
Yep, great. Are there other interesting companies that you could think of that you've been engaged with in the past?
Well, the dairy industry up in Clinton worked with them in the past as well, but also looking to see what they might be, I think, working on from an innovation perspective. And then Matt mentioned it earlier, the combination of introducing hydrogen into a natural gas supply, a hybrid type of a situation. I think that's something to keep an eye on.
Yep. Yep. I know that E2Tech also has a couple of companies that work with the dairy sector in terms of digesting waste to make methane and natural gas.
Yeah, I think was it the Flood Brothers, Suzanne, that recently implemented that renewable natural gas with the combined heat and power?
Yes, and a biodigester up in that's the Clinton project. And I mean, I think that what Matt and I are really interested in is hearing from people not only on the line, but maybe interested in this on the, we're here for some years to come. So, and growing in our capabilities all the time. I think the idea that we're connected with a larger network across the country is we can problem solve in ways that might not be obvious, I guess, because we can ask questions of the network and find out what others have done around the country to solve issues around cleaner energy, more efficiency.
We have a question from Woody at the Mid-Coast. Woody, do you want to say it out loud?
Sure. We're a little different. Seem to say that a lot, but we have our own power company, Brunswick Landing Electric Utility. Would we qualify as an entity, or would it have to be one or more of our customers that actually worked with you?
Generally, we're working with the end user.
Yep.
Okay.
Because I mean, we'd like some batteries too. We'd like some more solar. We'd like the other things, but we're also working with especially our bigger customers, for behind the meter solutions for them as well. So
definitely interested in talking more about it. We're identifying kind of what's in and out of the portfolio as we go. Okay. So definitely interested in continuing that.
Great.
Good.
Are there other questions from the participants? Like to speak up? In the meantime, I'll ask in terms of Aroostook County, because they're not part of ISO New England, but they get some of their electricity from Canada. They're also sort of a unique entity. Does it matter for folks up there?
No, I mean, so we're looking really to help these entities become, produce energy on site. So where they get their power from is not really a factor.
Okay, great. Do you have many clients who are looking at wind as opposed to solar?
We do include wind in our assessment. I can't say that there's been a rush towards people developing wind. Again, this would be like a manufacturing facility, and so it would be on site. So we're not looking at development of wind farms, but this would be one technology. And the Deer Island plant in Massachusetts uses wind, and they like it because it's a billboard, right? Showing that they care about renewable energy. So in some cases that visual identity is beneficial to the entity, in some cases it's not. We're definitely interested in learning more about Maine, more about the industries that would potentially benefit, more about the policies that are preventing businesses from moving towards some of these technologies, right? So we also have been asked to inform the DOE about some of the policy barriers that exist. Interconnection in the ISO New England is a big one. But if there are other barriers, right, like Aroostook County issues or other things, we would be very interested in learning more about that, learning more about programs. I showed one example of the battery storage program. I imagine that many others, and we would like to be sure that we understand them so that we can be sure that we're getting that information to the end user. So I appreciate the opportunity to kind of go over what we do, and would be thrilled to get more information, right, on you all's experience in Maine.
Great, thank you. Yeah, E2 Tech, we have a small number of large consumers of electricity who have been members. The one that comes to mind is Texas Instruments and their chip factory in South Portland. And I believe one of my predecessors had a sort of a small working group for some of these large consumers of electricity to help them talk with each other and think through how they might work and collaborate. And the folks from Texas Instruments reached out to me and said maybe that's something E2 Tech should get involved with again in the future. So that could be something.
Yes, that'd be great. Yeah.
Rob Sullivan, I see you sent a text chat thing. Do you have something you'd like to add verbally?
Sure. Sorry that I was late. I had an emergency.
If you want to turn on your video, we'll see you too. There we go.
So sorry I was late. I had an emergency I had to deal with. But Woody, if you want to call me at that phone number I put in the chat, I'd love to talk about projects you think might apply in your territory. And I just wanted to emphasize to everybody that wastewater and water treatment plants are all eligible for these IAC grants. They're considered manufacturing because they make good water out of gross water.
Good point. Yeah, I know that the Portland Water District and the Brunswick Water District have both been members of E2 Tech for that exact same reason as well. Good. Anyway, we're approaching the top of the hour, and I'm wondering if Suzanne, do you have some summary comments you'd like to give? Or Matt?
Well, just thanks again for giving us the opportunity to meet with your members. And you know, we're getting this thing going, right? We're a few months into this project, so we're eager to keep growing our connections throughout the region.
Great, thank you very much. The program was recorded and we'll be posting it on our YouTube channel in a couple of days. And so the folks in Maine who weren't able to join us today, again, it's middle of July, people are on vacation or doing other things. We knew in advance it wouldn't be a large audience for today, but that's why we record these so that other people can watch it at their convenience. So I appreciate you